to you.
Super. Thanks, Rob. That was a really great introduction. So I'm just going to share my screen now and bring up a couple of slides. I don't use this platform too much, so just bear with me for a few seconds.
So we are seeing your screen now, Sam, so just to let you know.
Great, excellent. Well, I'll get started. So yeah, thanks very much for giving us the time today to give you a bit of an overview of Evocon. The plan for today's webinar is we're a little bit restricted on time, so I was actually going to focus mainly on showing you the platform. But before I do that, it's obviously important for me to explain a little bit about how the system is actually put in place, because there is a hardware component and the software. So in regards to the hardware, we need to be able to pick up signals from the shop floor. So I'll focus a little bit on that at the start, and then I'll move over to show the Evocon platform. But before I do that, just to explain or give myself and Evocon a little bit of an introduction, if you haven't already had a chance to look at our website, Evocon's an OEE software, so a production monitoring software. And the whole idea of Evocon is we're trying to improve productivity and reduce waste for our customers. What we see, the key challenges that we're trying to solve are, first of all, manual data collection. When I say manual data collection, we see a whole range of different methods that might be from pen and paper, operators manually writing down on a timesheet where downtime has occurred, what the production output was on their machine. It might be actually inputting that straight into Excel, or it could be with an ERP system with maybe a custom developed application. But in all of those instances, we are relying on manual data input. When we're going down that route, then there's always the question about data integrity. If we're using humans or the operators as the source of truth to get that information, then we can never be 100% sure of what they're telling us is 100% correct. And we try to address that with Evocon by getting information straight from the source, which would be actually the machinery itself. Again, following that route, another challenge would be actually the intensive data processing that comes with that. If you're collecting data either manually or from other systems, you might be compiling that into various Excel spreadsheets, putting that together and maybe pushing it to Power BI to then finally get some nice visuals to understand what's happening. But there's a lot of time that has to go into that, looking through raw data and understanding what is the most important for you to identify the downtime or the main bottlenecks that might be occurring. Generally, also there's a lack of visibility if we're looking at those options that I talked about previously. If you have the data, it's probably not in real time, so you might be looking at yesterday's or last week's data. So you don't have that quick response time if issues occur, or actually being able to see in real time what's happening on the shop floor. Also, it's still very common. We see a lot of paper being used in factories, especially when it comes to quality or maintenance checks. That's something that we can help eliminate with Evocon. And then subjective opinion. So if we have any production managers in today's webinar, I'm sure that you can relate to this. There's a lot of different characters and lots of individuals or employees that we have to deal with across the factory. And each of them have their responsibilities, whether that's maintenance, the operators, or even the executives. They have their own motivations about what might be causing problems or issues on the shop floor. And quite often you might have to respond to the person who's shouting loudest without all of the information you need to make a calculated decision about where you should be focusing your efforts. And then the final one there is actually around effective resource management. World-class OEE is anything above 85%, but most manufacturers aren't achieving that. It's normally somewhere around 50 to 60%. And what that means is there's still a lot of untapped potential with the machinery and the resources that you're already currently investing in on the shop floor. So when it comes to the executives trying to push you to boost your output, and you might be under pressure and thinking, okay, we need to get more staff, we need to bring in an evening shift or maybe even new machinery, it makes a lot more sense to actually firstly understand what the current baseline is with those resources that you have and try and drive efficiency with those investments that you've already made. So that was my quick introduction to what we're trying to solve here with Evocon. I'm going to move on to talk a little bit about how it works. So I guess there's 3 steps. First of all, we automate the data collection from the machines. Second, we digitize that and transfer it to the cloud. We use Amazon Web Services as our cloud service provider. And then thirdly, we visualize that production data in real time through our platform. So here, in regards to automating the data collection, we've got various different options about how we can pick up the data that we require from the shop floor. This example that you can see here is actually with an optical sensor. So this optical sensor is being retrofitted to the side of the line, and Here it's actually just counting cement bags as they move down the conveyor. We take those signals from the optical sensor and then input, they're collected by our IoT device. You can see one on the screen. I've also got one in my hand here. Once the data is brought into the IoT device, it is then pushed to the cloud. And then the final step is we'll visualize that through the platform. We do expect operators to be engaging with Evocon. So it is essential that on the shop floor, they have some kind of device where they can interact with it. That might be through a PC, tablet. It can also be your phone, but there needs to be some way for the operators to get access to the Evocon application. I'll quickly just talk about a few of the different hardware architectures that we could have. What we've got on the screen here is the most typical setup. So this is an optical sensor counting units as they move down the production line. Obviously, on the image here, we've got bottles, but this could be anything from cement bags, fertilizers, window frames, you name it, but counting products as they move down the line. Those signals go into the IoT device. The IoT device has 3 inputs, so we can actually monitor up to 3 lines at one time. The IoT device needs to be connected to the internet. We can do that either via Wi-Fi, Ethernet cable, and we also have new 4G devices as well. So we've kind of got all bases covered. That information is then pushed to AWS, like I said, processed, and then shown back through the Evocon platform. So this is one setup. Another one would be, if you have continuous production, whether that's an extruder or if you're a sawmill, you can fit, for example, an encoder wheel and measure the length of the product coming out. Another option, if you're a machine shop and you have a lot of CNC machines, instead of actually counting production signals, we can set Evocon to be as registering time, so what we call time mode. And there we'd be monitoring just the uptime and downtime of the machine. From the other option, if we can do this, we can also fit a relay kit to the machinery and pick up a signal from the PLC. So whether, if there's an appropriate signal where we can get a production count, maybe there's a certain movement of the machine that indicates when a certain cycle has been completed, we can do that via a PLC and a relay. The final option as well, and this is just kind of highlighting how we cover all bases, is if you're already collecting this data and it's on a server somewhere, maybe locally, we can have a small program to run on your server and push that back into the Evocon application. So the beauty of all of these kind of options that I've shown you is regardless of what machinery you have on the shop floor, whether you've got one old machine from 30 years ago and a new machine from 12 months, we'll be able to find a way to get the data that we need to drive Evocon. I'll just finish off these slides with just a couple of images of what that looks like with Evocon working in situ. So I'm going to stop sharing again now, and I'm going to bring up the application, and I'll give you a walkthrough of what the platform looks like. Rob, yeah, you can see my screen again now. Great.
Yeah,
so
I can see that.
Super. Like I previously mentioned, Evocon's a cloud application. So when people want to get access to the system, they just do that through any device that can connect to the internet. You can use any internet browser. It's absolutely fine. And I will just mention now, the way that we license Evocon is based on per station. So per station that we're monitoring with Evocon. But when it comes to users, as a company, you have unlimited user access. So there's 3 types of users that we have within Evocon. One would be ship view users. So these would be the operators on the shop floor, and they would have access just to the ship view, which I'll show you in a moment. Then we have office users. The best way to think of them are their read-only users. They can get into the reports and the dashboards, but they can't actually change any of the settings. And then the final one is company admins. But as the beauty of being a cloud solution is you can log into this anywhere in the world and see in real time how your factory is performing. So without further ado, let's log in. So I've started here on dashboards, but I'm actually going to come back to this view in a moment. So I'm going to actually go to shift view first off, which is kind of our bread and butter. So to give you a run through of what we're looking at the screen here, currently I'm looking at line 1, which is also called the alpha line. At the top here, I can toggle between the different stations that I've got associated with this tenant. I've actually got 2 factories connected here. So these would be actually 2 different locations. We've got factory 1 and then factory 2. At any point, I can toggle between these stations because I'm a factory admin, so I have I'm a company admin, so I have full access. So if I quickly click to the beta line, then I can see the information there. Let's go back to the alpha. So Here at the top, we can toggle between the different stations. Next to that, we've got the shifts. So today's Thursday, 27th. This shift is what's being currently happening on that machine. And this is updating in real time. So as we go through the demo, you'll see this line move across the screen here. I can also go back to any previous shifts in time. So this is all of the data that's been collected since this factory has been connected to Evocon. But let's just stay on the current shift now. At the top left-hand side here, we've got the quantity that's being produced in this shift. We've also got the current product that's being made, which is a berry drink at 500 milliliters. And I can also see the previous products that have been made. Over here, we've got a couple of widgets. So currently, this is speed. This is the speed of the line. And then we've also got OEE. So OEE is taking into account the availability, performance, and the quality. And this line is currently performing at 83% OEE, which is very good. And then also in the top right-hand side, we've got Mr. Evocon. And because of this OEE performance here, 83%, he's very happy. As a company, you can set the thresholds for how Mr. Evocon is reacting to the performance of the line. So if you say if the OEE is under 40%, Mr. Evocon's emotions will change to give a little bit of a visual cue to the operators about how that line is actually performing at any time. But it's got three emotions, so sad, neutral, or happy. Then coming down to the actual view in the center of the screen. So each of these bars represents an hour in time. So this shift started at 6 o'clock and it's going to finish at 2. We use a traffic light system to indicate how the line is performing. So green means that the products are going through their ideal cycle time. Yellow means that there's been speed loss, and then red means there's been downtime. We also have these darker bars here, or grey bars, which is also downtime, but when the downtime occurred here, this was planned downtime. So we have a shift handover where this factory actually allows for 20 minutes for the shift handover, and we also have a break for 30 minutes at 10 o'clock. So the reason these are grey instead of red is because these downtimes, when that downtime is occurring, it won't actually have an effect on the OEE score. Now, as I said previously, we want the operators to be engaging with Evocon. They're the best source of information to relay the data about how that line is performing during the shift. But as an operator, what do I need to do with this? So at the beginning of my shift, I would actually come to Evocon and register that I'm going to be responsible for this station. So Vincent Vega is going to be the person running this line. So if I select him here, I can select multiple people and add different start times, but just for this purpose, I'm going to say Vincent Vega is responsible for the whole shift from 6 o'clock until 2. Press save. And then what you'll see over in the top left-hand corner, Vincent Vega now is registered for all the data that's going to be occurring over this time. Now, my downtime is actually being commented already, but I'll show you what his main objective would be here, which is actually to tell us what's occurring on the line, and mainly that's commenting on the downtime. So if I'll jump to a different line. Yeah, it's a little bit better. So let's pick Richard Branson for this line. But what we can see here, so we've got downtime that's occurred. There's a light red box, and there's also the darker red box. So the light red box means that hasn't been commented on yet. So there hasn't been a reason added to that downtime. So after the break, we've got 30 minutes that's allocated, but actually the machine took another period of time before it actually started running again. So Richard's duty, or Richard's task during his shift, is to click on this downtime, add a reason. As a company, when you configure Evocon, you would add your various downtime groups and then the associated reasons. I'm going to say that after the break here, there was a technical reason and I had to reset the machine, and then press save. And you'll see that that downtime has gone from light red to dark red. So as an operator, that's one of my main responsibilities. The other input I need to give Evocon is actually tell Evocon what product is being produced. So at the beginning of this shift, I'm going to say we've already made enough berry drink because we can see there's been 345,000 of those produced, and actually the target quantity was 500. So let's start making a new product here. I'll click on the signal, add a changeover. Here we've got my different product groups here, and I'll say actually we're making the 750 milliliter cola drink. You can also add a target quantity. I'm just going to put 500 here. You can also add a lot or batch number if that's appropriate, and then I'll press save. Now what we can see here, so the changeover happened at the beginning of the shift. As the shift has been running, we've been making the cola drink, and actually at around 5 minutes past 11, I actually hit the target quantity that I put in, so we can see this finish flag. So actually at that point, that would be a visual cue to Richard that he needs to start working on the next product. So again here, he'd add a changeover and say, okay, the cola drink has been finished. Now working on the 1 litre lemonade. I'll add a bigger target quantity of 2,000. What you can see also back at the top here is now we're working on the lemonade drink. These are all the lemonades, and actually the target quantity is 2,000. Currently on line 2, we've only made 243. So until 2,000 is reached, this product will continue to be made on this line and carry over into the next shift. So another thing we can see on the screen here are these little red dots here. Now, when it comes to quality or maintenance tasks in Evocon, we can integrate that into the shift view. So this is a feature that we call checklists. And there's been 2 checks that Richard was meant to do on his machine during the shift here. So I'll just click on this. This is actually a machine inspection, and this comes through every 600 products that are produced. You can give a little bit of instruction about what this check is about. And the first check that Richard needs to do is check the oil level on this machine. He's got a preferred range, and if, for example, we've put 1.1, then actually that's out of range, and he's given a note that he needs to notify maintenance. But actually, he mistyped, and the oil level was fine. The next check he needs to do is wipe off the residue. That's been done. Complete a visual inspection, done, and yes, the machine is running correctly, and then press save. Now you can see that that checklist has gone from red to green to mean that's been successful. And maybe if I do the same again with this one, but actually I put the oil level incorrect and press no, you can see this is orange to say that it's been unsuccessful. All of these checks and the data related to them are in the background. And when it comes to these checks, we can also enable authentication. So when a person actually fills them in, they have to define who was that appropriate person with the PIN code. So that would be my quick overview of Shift View. One thing I missed actually, when it comes to scrap, so there's various different ways that we can pick up scrap with Evocon, depending on what your production process looks like. One would be that we can pick up scrap automatically. So if you have some kind of visual inspection tool that picks up defects and then puts them down another line, we can fit a secondary sensor to pick up that scrap. The other option is that the operators can tell us that information. They can either do that as the products come through. So maybe this last signal that came through was actually scrap. I'll say there that there was a jam up and then press save. And then that signal or the count that came through at that time is now registered as scrap. The other option is they can add scrap manually at the end of the shift by clicking this button here, adding scrap, and go through the same process. But moving on. So that's my overview of Shift View. Then let's dig into the actual data. So going to factory overview next. Here, as I said earlier in the call, we've actually got 2 factories that are linked to this tenant. So we've got factory 1 and factory 2. We can toggle between the view here. So these are all the machines that I've got connected. But if I just want to see, for example, what's happening at factory 1, I just untoggle that. At the moment, things are working very well. So each of these lines are green, means that they're running, and they're also working at their ideal cycle time. Mr. Evocon is quite happy and pleased at the top here. And generally, this OEE is very, very good. You can also go to a timeline view. And if I bring back in the second factory, and we can actually have a timeline of both of these factories and all the machines to quickly see, a pulse check, I guess you could say, of what downtime has been occurring. So that would be the factory overview. Very common for our customers to have this on a prominent display somewhere in the factory. So when the production managers or anyone walks through, they can do a quick look up and see how the factory is performing. Next view would be dashboards. So here we have various different what we call widgets. So this is the OEE over the last 7 days. We've got OEE over the last 30 days. Another different way to view that OEE as well. And we've got the main downtime reasons. You can create as many widgets as you want within Evocon, and I'll just give you a quick example of that. So if I start a new downtime widget here, and maybe I want to look at just the previous shift. I don't want to look at all factories, just factory 2. And maybe I want to take out the uncommented stops. And I'll just press save on this. Oops, sorry, I forgot to pick my stations. And I've selected that wrong. Excuse me. So we actually want to take out uncommented. That's better. There we are. So yeah, you can set up as many widgets as you like, and different teams can have their own dashboard. So maybe maintenance wants to actually just understand all of the engineering related downtime that's occurred. And also we can set these different dashboards to be on rotation. So again, very common that these are somewhere in a predominant place in the factory, and we can rotate between the different dashboards to view the main KPIs that are important to you as a factory. Now, finally, let's go into reports. So within Evocon, we have various reports that you can interact with within the user interface. We've got downtime, speed loss, scrap, OEE, quantities produced, time usage, and checklists. For the sake of time, I'm just going to focus on the downtime report here today. But in the background, as you can imagine, we are collecting a lot of information and data about your factory's performance. If there is ever an instance where you can't find the required information within the user interface, we can also create custom reports for you to manually export that data to interact in your own way. But focusing on the downtime report here, so currently we're looking at downtime over the last 7 days for all factories, all stations are selected as well. So we can see here that actually the main downtime reasons haven't actually been commented by the operators. But if I go down to the bottom here, I might want to exclude various stock groups. So let's take our uncommented. What you can see here is this graph is dynamic. So again, if I take out maintenance issues, I can see what the main bottlenecks here are straight away. So product changeover is causing quite a bit fair loss of time. Material shortage has happened quite a bit. So actually, if I want to dig into this a little bit deeper, maybe I'll click on here. Currently looking at weeks, so maybe we want to look at a bit on a daily basis by changing the x-axis. Then we can see that on the 21st of June, there was definitely some issues, and I can dig into them a little bit further. At any point when you are playing around with these reports, you can always access the data underneath and export that in CSV format. And also when it comes to applying various filters to get a report that you might like to use during your weekly stand-ups, you can press save up here. I've got a saved example on the top left here to show you already. So this is my downtime report for the last month. And I can see the average duration because I've added a second y-axis here, so the duration time. And here I can dig in to see, okay, what have been the main bottlenecks for us over the last month? We've definitely got a bit of a problem with shift handover. So let's see if we can bring that down. Next, I would work through electrical failures, so get the maintenance team involved and see what we can do to improve. But these reports, as I said, dynamic, very easy to use, very easy to actually get the information in a way that you can consume and share. And then in regards to getting the data out into third-party applications, that's still quite commonly done. Maybe you have different business systems across the factory or software solutions. So in regards to getting data out, we have we're very open with our API, and you can automatically export data to other systems like Power BI. So I think that would be my main whistle-stop tour of Evocon. I can probably show you a lot more if we wanted to, but I think, Rob, shall we finish this demo, because I believe that we've got some options for people in regards to them being able to view Evocon after, or maybe you can think of maybe something else that I should show today already.
No, I think you've covered it all. I mean, you were quite quick there, which is great. So it might be worth, just before we discuss next steps, just talking about I guess how it's configured and what the options are at a high level in terms of setting up what the ideal cycle counts are and setting up lines and just maybe talking just for a couple of minutes about that.
Yeah, sure. So yeah, in regards to setting up Evocon, the real beauty of it is it's very quick and easy for you to get up and running. As I explained with the different hardware setups, the quickest way to get Evocon set up in your factory would be to retrofit new sensors. But then when it actually comes to configuring the system, if I just go into the settings here, normally the setup time to have one line up and running, you're looking at about 30 to 60 minutes of setup. So that would consist of you adding the appropriate users for the company, adding the operators that would be using Evocon on that line, adding your stock reasons. So very easy to add those here. We can add different groups and add the appropriate reason. Then we would want to add your products. But again, working through the user interface and doing this yourself is quite an easy task. If you have quite a lot of products, or you already have your stock groups and stock reasons predefined, you can also provide us those settings in a template, and we can do a bulk upload to get you up and running even quicker. So yeah, I think that would be my piece, I would say, Rob.
Yeah, brilliant. No, that's great. It leads us nicely on to the next steps. I think we are going to finish a bit early, guys. Actually, we've still got 15 minutes left, but I'll just briefly describe the next steps over the next minute or so, and then we'll open up the Q&A.